Okay, we're in section 6 of the notes, and we've covered the lecture material. Hopefully you paid attention and that you're ready to start problems. Again, for the students that it might be, the lecture might be going too quickly, you can always rewatch the lectures later. And there's also embedded videos in the notes that you can watch. Now, we certainly covered the properties. The big properties that we're going to be using is basically the addition of constants and the multiplication by constants. The multiplication constants, some students find tricky, but you should pay careful attention to that. As we go through examples, we will pay careful attention to that. So what we're going to do now, certainly go through problems. As we go through problems, I'm also going to speak about the notation again. There's a graphical way, there's a set builder way, and there's an interval way. And we'll talk about that as we do the examples. All right, I'm going to switch to the whiteboard now, and I'll do one example at a time. I do want to claim when you're looking at the notes, though, in the notes, when the examples, you'll see a little video next to it that would pertain to this particular problem. And you could watch me do that at a whiteboard, an individual problem. Generally speaking, their little spot videos are not long. Lectures, of course, are longer. All right. So I'm going to be doing these problems at the whiteboard. Now, when I do it at the whiteboard, it may look different than what I do over here. And the reason for that is, I can't say it's going to look substantially different, but it might look a little different to you. All right. Here's the deal, though. Whether it looks different or not, the answers will always be the same, provided it's a truthful answer. All right, and that's what we're looking to come up with, truthful answers. So I'm going to go to the whiteboard. And we're going to look at one problem at a time. And the first problem I want to do is, problem number 1. All right, now if I'm looking at this over here, my claim over here is just, reading it says solve, graph, and express the solution using the set builder and intervals. All right, so what I'm going to do is on the side, I'll write the problem down for you. And what I'm seeing minus 4x. And if you were going to read that, that's less than or equal to minus 12. Right. What I'm going to do, and I'll write it down for you, I'm going to divide both sides by the variable's numerical coefficient, which is minus 4. So divide both sides. There's two sides to this inequality by minus 4. Now you should know this is tricky. And the reason for that, when you divide by minus 4, the direction of the inequality is going to change. So on the left side, when you divide by minus 4, you get x. On the right side, when you divide by minus 4, you get 3. But the direction of inequality is going to face the other direction now, like this. So I'm going to claim this is the solution to the problem. This is a solution to the problem. I want to put down the graph now. The way I do this may be different than other teachers. I only put down the number I'm interested in, which is the number 3. It is so important you read an inequality from the letter. So this says x is greater than 3. Now, what does it mean to be greater than 3? It means it's to the right of 3. And what else is it? It could be equal to the 3. Our convention there is a shading. Okay, this is our graph. We'll look at the key later. This is the graph. I want to put intervals down next. I look at my number line, and to do that, what do you get? Well, it starts at 3. That's on the left. It includes it. Our convention is that square bracket there. And it goes where? It goes off to infinity. So this over here is intervals, notation. Last but not least, we're going to put down the set builder. Set builder is pretty easy, by the way. What do? You say x, vertical bar, that's read x such that, and just put the solution down. What solution? X is greater than or equal to 3. And this is set builder notation. Get my red pen out and see how we did. Were we able to graph it? Yeah, it's over here. Now I like their graph better, and certainly if you want to, if you're curious about that, I used Wolfram Alpha to do that. All right, so I'm going to say I got the graph down. I like their graph better, by the way. Let's see if I got the interval notation down. And again, I'm reading it. I'm seeing it. Did I get set builder notation down? Yep, I'm seeing it. Now, someone says, do you have the solution down? I do. I want to point out where the solution is. It's right in the set builder. It's right over here. I use that to write set builder down. So everything is done. Let's go to the next page. And let's look at this one over here. This is number 2. And again, I'll go through it in stages for you, all right? So what do I see? I see 5x plus 2. It's being compared to, if you want to read that, it does say it's less than this, 3x minus 6. Well, what I'm going to do is I'm going to subtract 3x from both sides. This has no effect on inequality. And I'm going to subtract 2 from both sides. All right, now what would you get if you did that? You would get 2x. Again, nothing happened in inequality. And you would get minus 8. Now what am I going to do? Well, I'm going to divide both sides by 2. Let's see if you did that. What would you get? Well, the left side, you'd get x. On the right side, you'd get minus 4. Now, dividing by a positive number has no effect on inequality. So I got my solution now. Next up, my graph goes down. On my graph, what I put down is I just put down the number I'm interested in, which is minus 4. And how's x related to that? It's less than that. And again, read it from the letter. It says x is less than that number. What does that mean? It's to the left. Right, this is the graph. Again, we'll look at the key later. Interval notation, I'm looking at left to right, minus infinity. No, you can never touch that. It goes up to minus 4. That's on the right side, and you can't touch that either. That's intervals. And set builder, fairly easy to put down. X such that x is less than minus 4. All right, let's look at the key. And I'm looking for these things. The graph is there. I'm seeing it. I like their graph better, by the way. I'm seeing the intervals. I'm seeing the set builder. And by the way, someone says, where's the solution? It's right here. I'm seeing it right there. Let's go to the next one. And again, it's not going to be substantially more difficult than the other one we just did. I'll write it down for you, though. And it's 2x plus 7. If you want to read that, it does say it's greater than 3 times 1 minus 2x. Again, what I would do is simplify each side separately. And then what I do is I'd add 6x to both sides, and I subtract 7 from both sides. And again, this has no effect on inequality at all. So what would you end up with? 8x, 7's disappear, right? And you get minus 4. All right. So what do you do now? I'm going to write it down for you. Divide both sides by 8. And 8's a positive number. So there's no effect on inequality. If you divide the left by 8, you'd get x. And if you divide the right by 8, you would get minus 1/2. And again, had no effect on inequality. This is the solution to the problem. What I'm going to do now, number line goes down. My number of interest is, sorry about that, is minus 1/2. And I got to read this. I'm going to say x is greater than that number. What does it mean? It's to the right of it. So I got my graph down. Again, we'll look at the key later. I'm going to put my intervals down now. That's minus 1/2. And it goes off to infinity. And again, you need to know those conventions. All right, what else? Set builder. Set builder is pretty easy. You use set notation, which is the braces over there. X, that vertical bar is read such that x is greater than minus 1/2. Let's look at the key. And go look at the graph first. Now, granted, I do like their graph better. They put decimals numbers down, but I put the fraction minus 1/2. And I hope you realize that minus 1/2 is where they say it is. I'm looking directly at that. All right, so that looks good. Did I put the intervals down correctly? Yes. Did I put set builder down correctly? Yes. Did I put the solution down correctly? Look at this. And the answer is yes, it's right over here. All right, let's go to number 4. And number 4 was known as a double. I'll write this down for you. It's a double inequality. Whoops. Someone says, why is it double? Well, let me explain why they call it double. It's double because there's 2 symbols of comparisons. Double inequality, double. There's 2 symbols of comparisons. By the way, it's also called compound inequality. All right, now why is it called compound? It's the way we read it. And let me read it to you now. This here is less than 25, and this is greater than or equal to minus 5. Well, what I like to do these inequalities, and generally they're not too difficult, but I realize there's 3 sides there. I'll write this down for you. That's the left side. This is the middle. Now these could be complicated, but I don't think it's going to be complicated yet. So what I want to do is I want to suggest to do something is try to isolate the x if you can. And I'm going to subtract 7 from all the sides. And what would you get? You get minus 12. Again, taking 7 has no effect on inequality. This would be 6x, and this would be 18. Now what are you going to do? Divide, not both sides, but all sides by the variable's numerical coefficient, which is 6. And 6 is a positive number, so there's no effect on inequality. So what do you get? Minus 2x. I'm dividing each side by 6, by the way, and 3. All right, what am I going to do now? Number line. And what goes on a number line? The numbers I'm interested in the proper order. There's 2 numbers now. So put them in proper order. What do you get? Well, minus 2 is clearly on the left. 3 is on the right. X could be equal to minus 2. And what is it? Greater than minus 2. And it's less than 3. I'll shade this all the way up till I get to 3. So that's a graph. This is the solution. This is the graph. Right? I'm going to put my intervals down now. Check with the key later. And what's that going to be? Minus 2, comma, 3. That's done. Set builder. X such that, put the solution down. Let's get a pen out, see how we did. Seeing this. I don't see the picture. I got to get to the picture. It's on the, I guess it's on the next page, right? Let's hold the thought in that. I'll go there in a second. And let me see if I have this down. Looking good, right? And the solution down properly. Well, I'm seeing it certainly is. All right, let's go to figure 4 at page 56. I'm on page 55, go to 56. And let's do that. And the picture's, it's good. Picture's good. All right, let's keep going. Let's try to do number 5 now. All right, this is called a double inequality because there's 2 symbols of comparison. It's also called compound. So let's start working on it. And the first thing I want to do is just subtract 2 from all the sides. And there's 3 sides, by the way. And what would you get? Well, if you did that, you would get 2x, and this has no effect on inequality, by the way, 8. And then I'm going to kind of talk through it now because writing it down really doesn't help me. But understanding what I'm doing now, which is dividing all the sides by 2, is helpful. And what do you get? Well, again, dividing by 2 is a positive number. It has no effect on inequality. That's my solution. I'll tell you why. I can read that. What does it say? X is less than or equal to 4, and X is greater than or equal to 1. My number line down. There's 2 numbers of interest, by the way. What are those 2 numbers in proper order? 1 and 4. Well, X could be equal to 1, but it's greater than it. And it's less than the 4. So I'll shade all up to 4, but it could be equal to the 4. So this is the graph. Intervals go down, 1 to 4. Again, I'm getting a little better at this because I'm practicing. And the set builder, well, that's pretty easy. X such that you put the solution down. Let's get a red pen out, see how we did. Interval notation. Now, I realize some people are saying they didn't answer the other stuff. Well, it's a good habit to get into putting all the stuff down, by the way. All right. They only asked for one thing, interval notation. All right, let's look at number 6. Again, it might look more difficult to you, but it shouldn't be substantially more difficult. And again, this one is an interval notation problem. I'm just going to pull it off onto the side, by the way. Just give me 1 second to do so. And I'll put this over here. We'll look at the answer key later. What I would recommend you do here is just simplify the sides. All right, so the left side, it's minus 8. There's not much I can do about that. The middle, I can definitely simplify. That would be 1 minus 3x. And minus 3 times minus 2 is plus 6. Again, I'm going to still recommend simplifying the sides. And the middle becomes what? 7 minus 3x. All right. So each side now is as simple as it gets. Now what do I want to do? I'm going to subtract 7 from all three sides. And what would you get? Minus 15. I want to repeat this. Subtracting a number from all sides has no effect on inequality. And let's see, 7 from 13 is going to be 6, right? And here comes the tricky part for some students. And it might look strange to you, but what I'm going to do, I'll write it down this time. I'm going to divide all sides. I don't say both because there's 3 sides, by the way. All sides by minus 3. Whoops, I didn't mean to put that down, by minus 3. Now, why is that? It's the numerical coefficient of the variable. And I want that variable alone. Here's the problem though. When you divide by if you divide or multiply by negative numbers, the direction of the inequality changes. So let's do one thing at a time. If you did minus 15 divided by minus 3, you get 5. The direction of the inequality is changing. If you divide minus 3x by minus 3, you would get x. The direction of the inequality changes. And if you divide 6 by minus 3, it gives you minus 2. I'm going to claim this as a solution, but I'll be honest with you, for some students, that looks rather odd. I'm not worried about if it's looking odd. I'm worried, can I understand what it says? Number line goes down. 2 numbers go on the number line in proper order. Clearly, minus 2 is on the left, 5 is on the right. And let me read it. And what does it say? As I read it, though, this may seem strange to you. It says x, I always read from this, is greater than or equal to minus 2. I know what that means. It means it could be minus 2, but it's got to be greater than that, which means it's to the right. Now, I'm going to keep reading it. And x is less than or equal to 5. I'll put that down. Keep going. So I know it's going to be less than the 5 or possibly equal to it. So I got my graph down. For students that find this difficult, reading that, you can rewrite this differently, and you can put in proper order. They both read the same way. They're both the same answer. I will say this, though. I would prefer to see this written down. The reason being it's much easier to read. It's proper order, right? But the box on both those means they're both right. Now, what else would I put down? Intervals. And what's the interval over here? Minus 2 to 5. I'm still going to put down set builder. And what set builder look like? X such that, well, I'll write down. You could either put down this one. That's set builder. Or if you prefer, you could put down the other one. What did they ask for, though? They asked for the intervals. Let's see if we got it right. And I'm going to look back over it. And let's look over here. Oops. Yeah, got it right. Okay. So someone's going to say, oh, geez, I'm glad that's over. It's not over. You have to study. You have to put the time and effort in. And how do you do that? Go back over the lecture material, go back over the examples, and then what you're going to end up doing after you do that is you need to start doing homework. So over here, you notice there's problems, and these problems over here, they're, certainly just like the problems we just did. What do you get? You get a problem. You're asked to graph it. The graph is provided to you. All right. You're asked to express the solution using intervals. I'm going to point out intervals are provided to you, and set builder notation. And set builder notation is also provided to you. So everything's being provided. I also want to point out, I'm going to publish lectures of me doing these problems at the whiteboard. And where do you find those things? On the website. All right. And you'll see that it'll say, section 6 homework. All right. You'll see that. All right. If you have troubles, though, after all the study and you still are confused, come by during office hours and we'll be more, I'll be more than happy to help you. Maybe I should say, everyone at Essex is there to help you through this material, by the way, including the tutors that are in the Learning Center. Thank you so much.